Hey everyone, this is Fred, and welcome back to the Quantum Bits channel. This is the second part of our little series of videos on the Amstrad CPC. In the previous episode, we dealt with the keyboard and the plastic case. Today's video is all about floppy disk drives. Indeed, after years of online research, I finally got my hands on an Amstrad DDI. We will also have a look at a modern replacement, the DDI-5 device by Zaxon. Oh, by the way, this is not my voice. Hopefully, I will have soon good audio equipment for proper recording. But enough chit-chat. Let's jump into it. For some reasons, Amstrad floppy disk drives are not easy to find nowadays in France. It took me more than a year to find one in decent shape and at a decent price. I'm always a bit nervous about postal shipments, so I can't wait to open the package and see what condition the hardware is in. There wasn't a ton of packing material, but so far everything looks okay. This part is actually the disk drive interface. It plugs into the CPC edge connector and drives the floppy unit. This is the floppy disk drive itself. The combo is often called DDI-1 in Amstrad ads. It looks okay, but during the shipment, the connector on the back was probably pushed, and it seems that something broke. As you can see, there is a dent here. Let's remove the ribbon connector and take a closer look. Yikes! This is not good. The connector is pushed inward and wiggles a bit. Hopefully it is still working, but I'll have to fix this. Let's investigate. This is a piece of rubber. It probably comes from the belt, which is known to crumble into parts. To open the disk drive, you will have to remove all the screws that are circled here in red. Let's take a moment to take a look inside. This is the disk drive itself. This is the power supply. Finally, these are the power switch and the relay PCB. I have removed the relay PCB so that we could take a closer look at the connector. Let's zoom in. As you can see, the connector is a bit loose and wiggles when I push it. Let's push aside the transformer to take a better look. Now, let's flip the relay PCB. As you can see, one of the plastic stand broke off. It is not a huge deal, but I will have to fix this later. All the internal parts are now removed. During this process, I collected pieces of the drive rubber belt everywhere. It is totally ruined. Remnants are wrapped around this pulley and the brass drive capstan over there. Let's start the cleaning process, first with the enclosure. As I usually do, I start my cleaning process with a warm, soapy bath and a lot of scrubbing. Once dried, I finish with IPA, then anti-static foam, then 303. It looks and smells much better. Great! 2 weeks have passed. I ordered online a replacement belt and I have just received it. Now comes the cumbersome process to clean the remnants of the belt that are stuck into the pulleys.
Before putting the new belt on, I'm gonna have first to lift the PCB, and to do that I'm gonna have to remove these 3 little screws, then carefully lift the PCB and try to clean up the pieces of the old belt. It took me a while, but I could finally clean up the mess. For this I had to wear these stupid glasses because my eyesight is not the best in the world. But finally it's cleaned up. Okay, off camera it took me about 15 to 20 minutes to put that damn belt on. It involved a lot of sweat and swearing, but in the end, yep, it's working. In the process of putting back the belt on, I had to wiggle this little connector quite a bit, and I don't like the shape of this or the joint, so I will have to flow fresh solder on them. And there we go. Nice connector, nice time to put everything back on.
Now it is time to service the drive. First, I spray IPA on a chamois swab to clean the head. Then I apply white lithium grease on all the moving parts of the drive. Finally, I clean up the PCB with a glass cleaning paper towel soaked in IPA and a toothbrush. I remove dust from the power supply with compressed air. Then I took care of the broken stand with hot glue. Let's take a closer look at the disk drive interface. Here are the main components. This is the floppy disk drive connector. And this is the 50-pin edge connector. This IC is the floppy disk controller. This is the floppy disk interface IC. And finally, this is the ROM. Let's clean the edge connector with contact cleaner. Throughout the 80s, floppy disks were available in different sizes and formats. Created in the late 70s, 5.25-inch floppy disks were probably the most common ones. They were notably used by the Commodore 64, the Apple II series, and of course the IBM PCs. In 1981, Sony introduced the 3.5-inch floppy disks. They were widely used in the mid-80s, most notably by the Apple Macintosh, the Atari ST, and the Commodore Amiga. But Amstrad followed another path. Alan Sugar chose 3-inch floppy disks for its line of 8-bit computers. This was a typical Alan Michael Sugar move. The choice was not motivated by technical characteristics, but rather because Sugar secured an exclusive deal with Hitachi. Truth is, this format was not a success. This disk format was mostly used by Amstrad 8-bit machines, the Ulrich Atmos, the Tatting Einstein, and Sinclair machines when Amstrad bought the company. And almost no one else, unfortunately. This was a bit of a problem because around 1986, these disks were very difficult to find. They turned very expensive. There were even rumors of stash of diskettes somewhere in Spain. As far as I remember, I only own a dozen of disks because these things were just too damn expensive. Here are 3 sets of disks to be tested. This is a pack of 10 unused disks that I bought online. These are system disks for a CPC 6128. They were kept for years by the father of my wife. This one is also from my father's wife. I think it is some kind of word processing, a sort of early desktop publishing app. We will try this one on the next video. Okay, I'm powering on the floppy disk drive. Now I'm powering on the computer itself. For this very first test, we will try to read the content of the CPM system disk. Here we go. It's working well. Great. I've reassembled the floppy disk drive casing. Let's see if it still works. Good. Now, let's go further and launch CPM. Okay, I'm greeted with a CPM prompt. It's all working great. Though I love floppy disks, they can sometimes be a pain. DDI-5 by Zaxon is a modern alternative. It provides a floppy interface, uses a USB stick to store disk images, and a 512K RAM expansion. Zaxon also provides a 3D printed case for it. I bought one of them on the Sell My Retro website. About a month later, I received 2 packages. The first one is an OSSC upscaler that I ordered on the Amazon. This will mean that from now on video captures will be much better. The other one is Zaxon's device that arrived from Poland. Unfortunately, during transport, the package was partially crushed. Let's open the package and hope for the best. Okay, no, I'm done. Actually, I must say it looks very nice. Cool. Let's take a closer look. This is the up button. This is the down button. This one is for the menu. This is the A/B drive selector. This is the ROM switch. This is a reset button. And finally, this is of course the USB port. On the front, there is a little OLED screen, and this is the edge connector. Finally, this connector can be used with a physical floppy disk unit. Overall, the device feels very well built. The only thing missing are labels to identify the various buttons and switches. That's why I used Inkscape to create labels for the top of the shell and a big sticker for the back. I tried to mimic as much as possible the look of the CPC markings. This is how it looks printed on adhesive paper. Not that bad. It should do the trick. I used a scalpel blade to cut the labels. This is the final result. Let's put it to the test. I connected a USB stick to the Raspberry Pi seating on my workbench. I had already collected a set of Amstrad disk images. The USB sticks appeared on the desktop. All I had to do is copy the DSK images from the Raspberry Pi to the USB stick. Okay, the DDI is connected to the CPC. The USB stick filled with DSK files is plugged in. Let's turn on the computer. The OLED screen turns on. I navigate through the images and select the Alien 8 game. I type the cat command to list the contents of the current disk image. There you go. I'm selecting another image and type the cat command again. Great! Zaxon's device includes a ParaDOS ROM. This is a replacement for the AMS-DOS ROM. I must confess I have never used it, so I'm going to be quick about it. The Amstrad is off, and I'm switching ROM from AMS-DOS to ParaDOS. Okay, the ParaDOS ROM header is there. I'm typing the drive command. Cool. Let's go a little further and run a game. I am selecting again the Alien 8 disc. I think this was the very first games I played on my Amstrad. Okay, this is very cool. Let's try another image. Amstrad Diagnostics is a suite of tests. I downloaded the latest release and stored it on the USB stick. I'm selecting the diagnostics image. Let's run the program. Here we go. It sees the floppy disk controller as well as the RAM expansion. For the sake of it, I'm running a RAM test. Nice. Everything is passing. One of the great things about Zaxon's device is that it can act as a floppy disk controller. Before anything, let's take a look at the service manual. Amstrad floppy disk interface is a bit special in the sense that it feeds the controller plus 5 volt. This is something that we do not want. Zaxon's DDI is powered by the edge connector. Injecting 5 volt through the IDC connector would cause damages. On top of that, pin 10 is used for drive selection, but we want the DDI to be used either as a first or a second drive. Zaxon do not provide much documentation. Nevertheless, I could found a video by Ian Beta on the previous release of Zaxon's DDI. It contains a link to cable modification for connecting an FD1 drive, but alas, this link is dead. Fortunately, thanks to archive.org, I could access to a capture from 2018. There, I could get confirmation that pin 10 of the ribbon connector must be cut, and that the 5 volt connector must be disconnected. This is exactly what I did. First, I disconnected the 5 volt connector. I bought an IDC ribbon connector on the Amazon. Then I identified pin 10 and marked it with a pin. Then cut it with a scalpel blade in a wire cutter. It's time to test this contraption. The external floppy disk drive is connected to Zaxon's DDI via the modified IDC ribbon connector. Let's turn on the disk drive, then the computer. Zaxon's DDI is configured as drive A. The external floppy disk is drive B. Let's type cat. I can still list the contents of disk images on A. Good. Now let's insert a floppy disk and switch to B. Yeah, it freaking works. Okay, now let's run some tests. DDI is configured as B. The external drive is thus configured as the first drive. I'm switching to B. I'm inserting a blank disk and running the RPM program from the B drive. It's measuring a RPM of 306. This is fine. The nominal value is 300. Nice. Let's do something a bit different. Copying an image from the USB stick to a physical disk. During the copy process, DDI will be the A drive, and the floppy unit will be the drive B. I am using the Discology program, which was very famous at the time. From the menu, I am configuring both source and destination drives. I'm selecting the image of the Fruity Frank game on the DDI. Then I am using the Fast Copy item from the menu. It starts reading the image from the DDI. Meanwhile, I am inserting a blank disk in drive B. Data from the source disk is stored in memory using the RAM expansion. It's done. Now it starts writing the image to the diskette. The operation is completed. Good. Now I'm switching the floppy unit as the A drive and press the reset button. Okay, it worked. I'm seeing the files. I'm removing the green filter and launching the game. This is so cool. I love this game so much. Okay, let's go a little further. When I was a kid, I used to read this magazine and typed in tons of listings for my Amstrad. This is actually how I started to learn basic programming. Nowadays, these magazines have been scanned, and listings are available as disk images. Let's download these images and compile them into a single DSK file. For this, I need a tool to edit, read, and add files on DSK images. I chose IDSK because I can compile it from source and run it on my Mac. I'm on my Mac, and I downloaded the source code of IDSK. I'm compiling it. There are only a few warnings related to character encoding. Nice! It compiled, and now I have a command line tool to play with DSK files. I can list the content, export files, or import new files. From the command line, I use IDSK to list the contents of 2 downloaded images. Each of them include a single program in BASIC. I am exporting both programs and then importing them inside an empty image. There you go. I now have one disk image containing both programs. Before writing the image on a physical floppy disk, let's try it on the Retro Virtual Machine emulator. I dragged and dropped the image. I can see both files. Let's run one of the games. Okay, perfect. For fun, I drew a few stickers for my floppy disk compilations. This is the result. Not bad. On one side, I stored a compilation of 14 games written in BASIC. On the other side is stored a compilation of Kung Fu games. Let's try them. First, the BASIC games. The floppy unit is the B drive. Awesome. Now let's try the Kung Fu games. I'm switching the drive to Unit A because some games don't like to be launched from B. Let's try first Kung Fu Master. Great! And now, let's run Yi AR Kung Fu. Awesome! And that's it for today. In the next video, we will experiment with peripherals, a QuickShot 2 joystick, then an AMX mouse. We will also play with the SimBoss operating system. Thank you for watching this video. If you liked it, you can subscribe. Feel free to add any comments. See you soon.